In August 2024, the average daily sunspot number likely reached 299, more than double the anticipated value. This level has not been observed in more than 20 years. A fascinating twist in the current solar cycle is that its peak arrived sooner than scientists expected. When this cycle kicked off in December 2019, forecasts aimed for a peak in July 2025, with around 115 sunspots. But by January 2024, NOAA's Space Weather Prediction Center adjusted its forecast, now expecting the peak to fall between January and October 2024, with a more intense estimate of 137 to 173 sunspots. On October 15th, NASA confirmed that the solar maximum period had officially begun. However, NASA's announcement doesn't mean this is the highest level of solar activity we'll see. While the Sun has entered the solar maximum period, identifying the exact peak of activity will take time. Scientists need to track solar activity for months, possibly years, to confirm the true peak, only determined after observing a sustained decline. Notably, the past 2 years have already shown elevated activity, with frequent sunspots marking this active phase. Scientists now expect the Sun to stay at its maximum phase for about another year before it begins its gradual slide back to a quieter period, known as the solar minimum. This means the next few months are going to be critical, and we can expect severe geomagnetic storms and spectacular auroral displays. Many powerful solar storms in recorded history have left a lasting impact on Earth. The Carrington event is the most famous and intense solar storm on record. It occurred on September 1st and 2nd, 1859, when British astronomer Richard Carrington observed a massive solar flare. Just hours later, a coronal mass ejection slammed into Earth, unleashing an intense geomagnetic storm. Telegraph systems across Europe and North America went haywire. Some telegraph operators reported receiving electric shocks, while others observed that their machines worked even with the batteries disconnected, powered solely by the storm's induced electric currents. Aurora borealis displays reached as far south as the Caribbean, illuminating the night sky brightly enough for people to read newspapers outdoors. According to NOAA, gold miners in the Rocky Mountains woke up and made coffee, bacon, and eggs, thinking the sun had risen on a cloudy morning. 2 operators of the American Telegraph line between Boston and Portland could communicate for 2 hours using no battery power and working only with the current induced by the aurora. During their exchange, they even remarked that the communication was clearer than when their batteries were in use. Then, in May 1921, the infamous New York Railroad storm struck our planet. It was the most intense geomagnetic storm of the previous century. Although there were no satellite systems at the time, it still wreaked havoc on Earth's electrical infrastructure. Notably, the storm caused a fire at a railway station in Brewster, New York, and disrupted railroad signaling systems across the northeastern United States. In August 1972, a powerful solar storm struck Earth between the Apollo 16 and Apollo 17 missions to the Moon. This solar event was so intense that had astronauts been in space at the time, they would have received lethal doses of radiation. It also set off unexplained sea mine explosions off the coast of Vietnam, as the intense magnetic activity triggered sensors in the mines. Then, in March 1989, an intense solar storm brought Earth's modern electrical grid infrastructure to its knees. In Quebec, Canada, the storm caused a major blackout, leaving about 6 million people without power for over 9 hours. The electrical grid collapse was so severe that it caused voltage instabilities and transformer damage across North America. The event highlighted the vulnerability of power grids to solar activity and prompted new protective measures in energy systems worldwide. More recently, in early 2022, a flare from the sun was powerful enough to cause geomagnetic storms, resulting in the loss of 40 newly launched Starlink satellites. Today, our society heavily relies on satellites and various technologies that need stable magnetic environments to function correctly. This dependence makes us more vulnerable to the effects of significant solar activity. Any disruption could lead to trillions of dollars in monetary losses and pose risks to life dependent on these systems. The potential impact of a Carrington-class event today has been estimated to result in damages ranging from $0.6 to $2.6 trillion in the US alone. Now, we come to a crucial question. Does solar activity contribute to the increase in Earth's temperature, thereby causing global warming? During solar maximum, there's a slight uptick in the total solar irradiance, the amount of solar energy reaching Earth, which can cause minor fluctuations in Earth's climate. However, these variations are relatively small and have a limited impact on global temperatures. This graph shows a relationship between solar activity and Earth's temperature up until the end of the 20th century. The amount of solar energy Earth receives has followed the Sun's natural 11-year cycle of small ups and downs, with no net increase since the 1950s. Over the same period, global temperature has risen markedly, indicating that the Sun has not been the primary driver of the observed global warming trend over the past half-century. High solar activity can potentially impact NASA's Artemis missions to the Moon. Mission guidelines are clear: avoid launches near solar storms. This is due to the danger that the high-energy particles from these storms pose to sensitive electronics and the risk of disrupted radio communication, which could make maintaining contact with the spacecraft tough, if not impossible. But there's a surprising upside to all this solar activity. During intense solar periods, the Sun's magnetic field effectively shields Earth and its satellites from cosmic rays originating beyond our solar system. This means that high solar activity offers extra protection against cosmic rays, making satellites less vulnerable to the long-term damage these particles can cause. One of the most exciting things about the solar maximum period is the possibility of witnessing auroras. When a coronal mass ejection collides with Earth's magnetic field, it sets off a mesmerizing chain of events. As the storm approaches, Earth's magnetic field acts like a shield, deflecting much of the charged particles. But the magnetic fields of Earth and the solar storm can link up, creating a funnel where charged gas streams down toward the day side of Earth's poles, forming a rare daylight aurora.